Okay. Coulomb's law, the force experienced by one charge due to the other is given by Coulomb's law. We have F is equal to KQ prime over R squared, where K is a positive constant. Note that a positive F tends to increase the radius. In the SI, the unit of charge is the coulomb. To avoid very small numbers in practical work, the microcoulomb, when you say microcoulomb, that is 1 mu c, that is equal to 1 times 10 to the negative 6 coulomb. When you say 1 nanocoulomb, that is equal to 1 times 10 to the negative 9 coulomb. Now, since the force is equal to Q prime R squared, the F is in dyne. F is in dyne. The unit is in dyne, while R is in centimeters, that is the radius, and Q, which is the charge, is in ECU. When you say ECU, that is electrostatic unit or stat coulomb. Electrostatic unit, or also known as the stat coulomb or stat coulomb. And the conversion to coulombs, we have 1 coulomb is equal to 3 times 10 to the 9 ECU. Okay. And then the fundamental smallest charge found in nature is denoted by E. E. The value of this one is 1.60219 times 10 to the negative 19 coulomb. Okay. All other charges are integers, multiples of E. The electron has a charge negative E. Electron has a charge of negative E. Okay. While the proton charge is positive E. In the SI unit, the Coulomb constant K has the value of 8.988 times 10 to the 9 Newton meter square per Coulomb square, or approximately equal to 9 times 10 to the 9 Newton meter square per Coulomb square. Okay. Open K is replaced by, sometimes K is replaced by 1 over 4 pi EO, where EO is the has a constant value of 8.85 times 10 to the negative 12 Coulomb square per Newton meter square. This one is called, your EO is called the permittivity of free space. Okay, that's why we have another formula for F, which is equal to 1 over 4 pi EO times Q prime over R square. Okay, again, your F is equal to, for F now, is equal to K F is equal to 1 over 4 pi EO times Q prime over R squared. In vector forms, F2, the force on charge Q2. F2, the force on charge Q sub 2 due to the charge Q1 is given by F is equal to K Q1 Q2 R over R squared. F2 R squared. Or that is also equal to K Q1 Q2. And then we have R over R cubed. Where R is the vector displacement from Q1 to Q2. That is why we have R is equal to R bar, that this one as your R bar, over R. Okay. Now, the unit vector in the direction R. Example. Number 1, how many electrons are contained in negative 2 Coulomb of charge. What is the total mass? Of these electrons. Okay, the electron charge is negative E. Okay, remember that the electron charge has a charge of negative E, where E is equal to 1.6 times 10 to the negative 19 Coulomb. Therefore, in negative 2 Coulomb of charge, therefore in negative 2 Coulomb of charge, there are N, which is equal to 2 over 1.6 times 10 to the negative 19.